Turn on a gas stove and light the flame. The fire burns smoothly and steadily. Now imagine the plastic around you, flexible, durable, and everywhere. Both come from the same place, hydrocarbons. But not all hydrocarbons behave the same. Let's go a little deeper. Hydrocarbons are divided into three main families based on how carbon atoms bond with each other: alkanes, alkenes, and alkynes. Alkanes have only single bonds between carbon atoms. They are stable, less reactive, and burn cleanly. That's why alkanes are commonly used as fuels. But wait, here's the twist. Alkenes contain at least one double bond. That double bond makes them more reactive. Because of this, alkenes are used to make plastics, chemicals, and synthetic materials. That one extra bond changes everything. Now let's go even deeper. Alkynes have at least one triple bond between carbon atoms. These bonds store even more energy, making alkynes highly reactive. That's why acetylene burns with an extremely hot flame and is used in welding. Let's connect this to real life. Alkanes heat your homes. Alkenes build your plastic bottles. Alkynes cut and shape metals. Same elements, different bonding, completely different uses. Before we wrap up, zoom out for a moment. The type of bond between carbon atoms decides how a compound reacts, how much energy it contains, and where it can be used. And that leads to the next question. If different bonds control reactivity, how do common functional groups like alcohols and acids change the behavior of organic molecules? That's exactly where we go next.